should be okay now. Yep, okay. Well, at least, hopefully okay. So hello everyone. I'm ready to start with only a couple of minutes delay, just then. So first let me introduce myself. I'm Siniša Miličić. I'm a Vice Dean of Teaching and Student Affairs at Faculty of Informatics in Pula. Although I did work here for a whole decade, my office was just above here. I'm a mathematician, but at the University of Pula we have a smaller team of both developers and programming capable staff and all. So we share some tasks, and the task that I was working on since the beginning of the pandemic was student enrollment, making student enrollment as much online as possible, and we managed to do it mostly online, especially the critical steps. We are a small university, so University of Pula is as big as this faculty. There's orders of magnitude difference, but we managed to do it for the whole university. So this talk will go into a bit of CQRS and the event sourcing theory and what the software was about and how it worked, and a bit of an example of using the framework underlying it. So in 2020, we realized sometime in late June that we needed an online enrollment system, which of course is very, very short notice, because in the second half of July we have the main thrust of students enrolling at the university, so first year enrollments. And so we hacked something really ad hoc, and it was a really brittle stack because it was a completely unnormalized Postgres set of Postgres tables that would just work on that day and a few days going on. I think I switched from Flask to AIO HTTP in Python and Vue.js for the front end. And that was hacked together, and it worked really well for that enrollment and the following one. So no student needed to come at the university to fill out forms by hand and then do many of those data-intensive, people-intensive tasks that can be done automatically. But that piece of software was rather unmaintainable, and I had an error in the data, and then I wanted to change something. And you know, when you patch a table in production, during production, it may not happen. It may not be a happy scenario. So, and then we were from 2020 to 2021, we spent a lot of time thinking and a couple of days pre-deadline coding, because of course. And we decided that we needed something that would be an intermediate system based on an event bus that would cover ever more university administration functions coming from that ever more university functions that are related to administrating student data, their learning progress, everything. But initially, let's enroll them and produce the necessary enrollment data. Okay, and of course, why event sourcing there? Making something an event bus is a pattern of doing it. So let me just go a bit into the theory of the elements. So CQRS, command query responsibility segregation. The main idea of the architecture, it's an architectural pattern to separate stateful actions and views of those actions, so that you can rely on caching on one stream or channel and do the action stuff by different channel. I usually describe it in terms of the fact that most stateless activity in an SQL database is done through select, streams side, and most modeling manipulation is done through a completely different syntax. It's a weak distinction, but it's still a distinction. If you're writing a select query, you're highly unlikely to make a major change. If you're writing something with delete, you're quite likely to make the change and quite likely to make the wrong one if you're writing it manually. Speaking for experience. The main use case for such for such a pattern is when you obtain data by one means, by one kind of activity, and then view it completely differently. So, for example, when you get just a series of clicks or acceptances or some minor state changes, but you have a database in our case, a big database of student enrollment. We are talking about hundreds of students enrolling, and they are just doing one click. So that's a proper use case. So CQRS is definitely a pattern that we needed. But we also used event sourcing, which is the additional layer. So it's a version of CQRS where you have an event bus, usually recorded, that creates the full state of the system. So you can either contain the state, you can either record the state and its snapshots of the state, or you can take an initial state, for example, an empty one, and then add events as the derivative. So it's a kind of a Laplacian determinism. Generally, if recorded properly, it provides a replayable and auditable log for how data is mutated. It does come at a cost, because, well, if you want to replay something and that something at some point pays someone €1,000, then every time you replay it, it will pay €1,000. So you might want to worry on those issues. And on the flip side of the same issue, the right to forget and the audit log are in direct contradiction, because privacy right to be forgotten and an event log, if not designed properly, can clash, because, for example, you use someone's personal ID for a piece of data, and then you have to change the log to recreate everything without that person, and that may break things. So this requires a lot more careful design than CQRS in general. So I enjoy Python programming, so I started doing this in Python. And I wanted a pub/sub system, so I picked more or less at random Kafka. Then I wanted to see if there's something more lightweight that would produce anything similar, and the result was rather disappointing. To work around that privacy issue of the right to be forgotten, I realized that there's an advantage to the 1 megabyte message size limit in Kafka, that you should have Kafka provide just general metadata or general procedure calls rather than a types of data. So the way to work with that was to push everything that's big data or that's private data through a Redis, cache it there. So I can both cache it, and I can, if I need to delete someone's personal information, I can do it in Redis and then modify the event at the third part, not at the structural level. So I decided to have 4 streams, and that's a big, that was a design decision. We needed a command or a function call or RPC stream that would just provide commands, so where every actor would listen on, that every worker would listen on, and there is so it's a pair of streams, so that we don't get confused if something is just a confirmation of work being done or a new event. So any new event goes to the command stream, is pushed to the command stream, and the result, unless new events are gathered, goes through the return stream. So we have a command stream, push, and return, and a similar thing for queries. Now, a worker unit is something that listens on the command stream and listens on the query command stream, and then does actions or returns calls, so hierarchically subordinated. A manager is the exact opposite. All the arrows go in the other direction. It creates events, and it listens on the query stream for and creates queries, and then listens for the results on the other streams. Now I say soft segregation because the code is mirrored. It's and a certain actor can be both. Those are not in contradiction. Okay, so back from theory to what we had to do. There was there's a central hub of information for enrollment in students, and it's called Postani Student. It's actually, I think, based on the Heiko developed 3 floors from here. We needed to process enrollment data, generate 2-factor authentication, AI for login information, etc. There are some technicalities with tuition fee requirements, because not all students are required to pay tuition fees. Most, but 50% are not. Module selection, because, well, some faculties provide module level information at Postani Student. Example, philosophy faculty, in both here and in Pula, you choose English and archaeology, and that's good, and that's all fine. But economics faculty don't have that tradition. They demand that you enroll with them and then choose the module, and then that, of course, results in where am I time? Okay. That results in in the requirement to choose the module just after enrollment, and then the faculty actually chooses it for you because you might be over quota, then you get to a second choice, etc. So this was actually a required feature and a big process element. And of course, there were extra process elements being added, which also encouraged the use of some actor-like structure. Okay, so let me show you. Oops, no. Just a sec. Where am I? Let me. Of course, now all. Okay, great. So. Why did it go over there? I don't know. Okay. Live switching window managers is actually worse than live coding. I promise you that. Okay, so we have this. Then I have yep. And I need a password. Sorry. I need to add a widget. Works. Where is workspace list? Yep, this is not. Just a sec. Sorry about this. Activity pager, is that it? Yeah, but not here. I want it on. Nope. Doesn't work here. Can I go? Okay, so for some reason it's trying to open on a different Firefox on a different server and side, and that's really. Am I even connected to the internet? Yep, I am. Oh yeah. So. Do I have that? Oh yeah, I have it for Score. Okay, so okay, I managed to put it under control, although I had to open a different one. Nope, didn't work. Oh, that's why. And this is the password. So the idea was that you had you had to accept the general terms and conditions, and then pick the module at the economics faculty, and then why is it not creating? Of course, things are not supposed to fail when you do it live. This is fake data, of course. It should provide a QR code here. No, acceptance of enrollment. Yeah, and then there's a payment QR code for payment processing. So each element of this is provided by a different service. How am I doing with time? Okay. So instead of live coding, which I did promise, at least I'll try showing the general code for the yep. Okay. The main part of the code was this part XP supply, which is perhaps no. I wanted to show it through a service rather than this. Student status service. Okay, so. This is a large import of things, but the general idea is in the main, we just gather query reactions, has accepted terms and conditions, goes to the function. It reacts to these commands on Kafka, and they are so this is line 89. Everything, the whole code is just a bit. Okay, so this is the whole code, and there's some, it could have been refactored even easier. So these are the commands on the Kafka log. These are the actions that it can take, and so new bulk student status import. That's assertive worker. Nope, can accept enrollment. This is new students. Where is new students? Okay, so I'm getting a bit lost. New students it just so it receives a Redis reference by the framework, given by the framework. It gets data from Redis. Of course, this was an ad hoc choice to push pickled data through Redis, pandas pickle in Redis, but it provided a rather simple piece of information. Now, those are new students, so we needed some defaults. And this is the part of the service that just adds a list of new students with some checks. If anything fails, this wrapper then provides failure information. So I've checked the statistics. It's about so we had 10 services of about 3 kilobytes each, and the framework was about 400 lines of code all in all. So it's really simple. Now I think I'm out. Okay, so just one more sentence. There are some technical issues with Kafka. Privacy I've commented. Of course, there's a possibility of actors acting up and flooding the action system, because, for example, some of them might even produce actions. And of course, since it's very short, it's a didactic instrument along with the live system of services for providing future stuff that currently we don't support at the uni because it's a complex system. Sorry. Thank you.